In this little video, I'm going to briefly talk about what inverse variation is, and this is in the very, very basic sense. I'm not going to go into too much depth, just because it's not required of us this year. But anyway, so inverse variation is basically saying what you see right here. And if you want to pause the screen and take a second to read this, I'm just going to go ahead and summarize it anyway. All it's really saying is that, for example, as x approaches infinity, so as x increases, right, then that means y approaches zero, so y decreases, right? And it's not going to decrease past zero. It's just going to approach zero, right? And the opposite could also be true. You could also say that as y increases, you have x approaching zero, right? And that's all that this is saying. Okay, and it comes from just this little relationship here, right? If x times y is equal to some number k, and again, we're assuming x is not equal to zero, right? Then we would say k is what we call the constant of variation. And that gives us this little function right here, which represents very wholly the inverse variation between y and x. Okay, so here we have some examples to, apply what it is I'm talking about. So let's say when x is 5, y is 10, and they vary inversely. So we're going to use the inverse variation relationship here to find what y is whenever x is 25. So all I'm going to do, I'm going to go ahead and just write out y equals k over x, because we're told that they vary inversely, rather, right? X and y vary inversely one another. And the next thing I'm going to want to do is just plug in, right? So I know x is 5, and I know y is 10. So whenever x is 5, y is 10. Okay, and I can easily figure out my constant of variation, my k here, just by multiplying by 5 on both sides. And when I do that, I plainly see k must be equal to 50, right? So now that I know k is equal to 50, I can rewrite this again, y equals k over x. So I don't need to say k over x anymore. I can go ahead and just say y is equal to 50 over x. And now I can figure out what y is whenever x is 25, right? So when x is 25, well, pretty obvious, y is going to be 2. So y is 2 when x equals 25. And we see that as x increases, y decreases, right? So that's, again, another example of what we mean when we say that they vary inversely. So looking at this next example, well, now we're talking about the same relationship between the two, more or less, right? They're varying inversely, and we're told to assume such. So what about whenever x is 4 and y is 16? Well, we're going to do the same thing. So y equals k over x. Let's go ahead and figure out our constant of variation, assuming that y is 16 and x is 4. Multiply by 4 on both sides, and we get that k is equal to 64. And then from here, it's very simple again. So I'm going to say y equals, I don't need to say k anymore. I can just say 64 over, well, we know x will be 2 in this case. And we're just going to get that y is equal to 32 whenever x is equal to 2. Right, so we see y now increasing whenever x decreases. So that's really all there is to basic inverse variation. There's a lot more to this than that. But like I said, I'm keeping it super simple for this video. If you have any questions over inverse variation, obviously come see me or shoot me an email. Goodbye.